Hello students, today we are going to take up very important topic from chemistry, that is organic chemistry. Organic chemistry, in order to understand organic, one has to know what's catenation, what's chemical bonding, periodic table, atomic structure, nomenclature of organic compound, basic concepts of organic, acid and base, and redox reaction. So let us take up each by in steps. So let's take what is meant by this organic. Organic generally is referred as chemistry of carbon element. Chemistry in which carbon is one of the essential elements. But this definition is not up to the mark, because even calcium carbonate, you cannot consider it as a organic compound. It is inorganic compound. So what's the definition, proper definition? It is hydrocarbon and it is derivatives. Then why we are studying organic chemistry as separate branch of chemistry? Catenation. Catenation means, by catenation we means when something element can combine with each other to form long chains. So carbon is combining with carbon to form different chains. So straight chain, branch chain. So why carbon is combining and forming large number of different types of chains? Because first of all, carbon is very, very small in size. Secondly, carbon is tetravalent. So that is why this is showing the property of catenation. So catenation is the reason for separate study of organic chemistry as a separate branch of chemistry. Now here comes what they call it, why carbon is combining with carbon and making which type of bond? It is covalent bond. It is covalent bond. So this is from chemical bonding. So covalent bond, when mutual sharing of electron, this is Lewis concept. Then we are having orbital concept, when half-filled atomic orbitals are combining among themselves, overlapping among themselves, forming sigma and pi bonds. So here carbon is small in size, smaller the size, stronger is the bond. Second, carbon is tetravalent, tetracovalency. So this is from chemical bonding. In order to understand organic, one should know, first of all, one should know what is meant by chemical bonding. In order to understand chemical bonding, one should know atomic structure and periodic table. In order to understand chemical bonding or organic, which is to be applied in organic. For example, chemical bonds are covalent bond, ionic bond, metallic bond, coordinate bond, or metallic, this is hydrogen bond, etc. So in this case, this is all coming under the heading of chemical bonding. Then why certain elements are making covalent bond while others are making ionic bond? This is coming in periodic table, because electronegative elements will be combining with electropositive elements to form ionic bond. It means we are having electrovalent bond or ionic bond. When you are having such type of bond, what is the difference between covalent bond and ionic bond? In percentage of ionic character is less than 50% here. In electrovalent bond, the percentage of ionic character is greater than 50%. Now where comes this percentage of ionic character? This is coming from dipole moment. So whatever I am suggesting, so one should go it through, otherwise you will be always coming problem in organic chemistry. So covalent bonds are having percentage of ionic character less than 50%. Ionic compounds or electrovalent compounds are having percentage of ionic character greater than 50%. Or you can also say a difference in the electronegativity of two bonding atoms. If it is something 1.7, 1.9, etc., more than that, so then it is something ionic bond. If it is less than that, then it is covalent bond. So it means we are not having any 100% ionic or 100% covalent bond. So naturally here This is introducing concept of resonance. So here we'll be taking up the things slightly side by side, but one should understand all this. If one is not having the understanding of all this, then one is coming across problems. So periodic table is giving you electronegativity. It is something difference between, it is something the tendency of an atom to attract the shared pair of electron towards itself. It is coming in chemical bonding, but it is there from periodic table. Periodic table, we are having groups and periods. Horizontal rows are known as period, vertical columns are known as groups. As we move from left to right, what we are having, the ionization potential, ionization enthalpy and electron gain enthalpy are increasing. And as we move downward, these properties are decreasing. And electronegativity is simply average of the two. Electronegativity is average of ionization enthalpy and electron gain enthalpy. So this is coming in atomic properties or periodic properties, while electronegativity is coming in chemical bonding. So this is from periodic table, this is from chemical bonding. So naturally here we are talking about elements and the atomic structure comes into being. From atomic structure, you are having this electronic configuration. This word comes quite number of times, configuration, the relative arrangement. Electronic configuration means that we are having how the different various electrons are arranged in the space around nucleus. What is that space known as? The space at which the probability of finding electron is maximum, that's known as orbital. So this orbital term is from quantum mechanics. The term orbit or energy level, energy shell, that was there in Bohr concept as well as in quantum mechanics. So here we are using term orbital. For example, carbon is having this configuration: 1s2, 2s2, 2px1, 2py1, 2pz0. So here, this is the configuration in ground state. This is the configuration in ground state, the stable configuration. So atomic structure giving you what's the electronic configuration, what are quantum numbers, what are the shapes of orbitals, what are degenerate orbitals. For example, electronic configuration is governed by Pauli-Squarzian principle, then we are having Aufbau's principle, then we are having Hund's rule of maximum spin multiplicity. So this is from atomic structure. Then quantum number, for example, this has got S electrons are having L is equal to 0 for P subshell, L is equal to 1, and here what they call it, the magnetic quantum number is 0. In this case it is 1, 0 and -1. So one should know the quantum number. This first number is principal quantum number. The principal quantum number is 1 for this, it is 2 for this, 2 for this. So as a result of that, one should know quantum numbers, one should know the shapes of orbitals. For example, 1s and 2s, both of them are having spherical shape, but 2s is having what they call it node. So node means the space at which the probability of finding electron is 0. From where it is coming? It is coming from graphs. So whatever is not clear, you are supposed to bring the problems to me, or as we already mentioned, you can consult your teachers or your friends, or ultimately our aim is that to how to attain the mastery over things. So this is configuration, the relative arrangement of electrons in the different orbitals around nucleus. So this is why it is 2 electrons here, why one electron here. It is because of what they call it Pauli-Squarzian principle, and here it is because of Hund's rule of maximum multiplicity. This is p orbitals. So both electrons are having parallel spin. First of all, electrons will be pairing up only once each orbital of the degenerate set has been singly filled. and then the unpaired electron will be having parallel spin. This is Hund's rule of maximum spin multiplicity. Then why we are filling up 1s first and then 2s? It is Aufbau's principle. So one should understand all this. Then we are having nomenclature. Nomenclature, I am giving all this very briefly, simply because it is presumed that you might be knowing all this. But if still you are having any doubt, so there is nothing wrong in asking about that, because once you are not clear about the basics, it will be problematic for the further movement or further what they call it, understanding of the subject will be becoming more difficult. So nomenclature, so how to name. Naming is something, common names and IUPAC names. So naming, you are having, this is, naming is common names, IUPAC names and common names. So common name, for example, ethyl alcohol is known as this is known as ethyl alcohol because this is ethyl group, this is OH group, functional group. So naturally, what's IUPAC name? Here it is known as ethanol. Just H from 2 carbon atom, word root. This is word root. This is primary suffix. This is secondary suffix. Word root is indicating how many carbon atoms are there in the parent chain. And means whether it is saturated one or unsaturated one. All indicating the functional group. OH is a alcoholic functional group, so naturally for that we are using word all. So this is, we are having the nomenclature, so one should also know that. Besides this, one should know what is meant by primary, secondary, tertiary carbon atom. For example, here you are having this is primary carbon atom, this is secondary carbon atom, this is secondary carbon atom, this is primary, this is tertiary, this is primary. Because this is attached with 1 carbon atom, this is attached with 3 carbon atom, this is attached with 2 carbon atom, this is singly attached. So this is primary, primary, primary. This is secondary, this is tertiary. And if you are having this, this is quaternary carbon atom. Quaternary means carbon is attached with 4 other carbon atoms. So one should know what's meant by primary, secondary, tertiary. Primary is attached with 1 carbon atom, secondary is attached with 2 other carbon atoms, and tertiary is attached with 3 other carbon atoms, and quaternary is attached with 4 other carbon atoms. One should know because ultimately we are going to use them in reaction intermediates. Then you are having basic concepts. Basic concept, children, in basic concept, what's the requirement? In basic concept, you should first of all, what we are having, bond cleavage. Bond cleavage means how the bonds are breaking, symmetrical cleavage or unsymmetrical cleavage. Symmetrical cleavage or unsymmetrical cleavage. For example, so here so this is symmetrical cleavage. Each chlorine has separated, taken its share of bonded pair of electrons. So this is symmetrical cleavage, homolytic fission, or what they call homolysis. So this is first type of cleavage. Second, you are having this. So in this case, here one atom takes away both electrons of the shared pair. This is heterolytic fission, unsymmetrical cleavage. It is symmetrical cleavage, it is unsymmetrical cleavage. So this is the bond breakage. Why we are talking about bond breakage? Because when we are studying reactions, the bonds are breaking in reactants and new bonds are formed in products. So how bonds are breaking? Bond can break in a symmetrical fashion or unsymmetrical fashion. So this is what we mean by bond cleavage. Then you are having attacking species. Attacking species. For example, you are having reactant, we are having, since this is being attacked by this attacking species, and we are getting this product. So this is attacking species, something attacking upon reactant and giving you product. So what are the types of attacking species? What are the types of attacking species? In that case, we are having what they call it electrophile. Electrophile. This is electron seeking positively charged or electron deficient molecule. So this is positively charged species or it is electron deficient species. It is electron seeking, electron loving. This comes from this acid and base. As acid and base, for here it is Lewis acid. You are having BF3, aluminium chloride. You are having this H positive ion. Then you are having nitronium ion. So all these are electrophiles. Why BF3 is a Lewis acid electrophile? Because in this case the sextet of electron is there around boron. Octet is incomplete. Here again same situation. You can also have the sulfur trioxide. Sulfur trioxide is also electrophile. So electrophile may be positively charged or it may be molecule having electron deficiency. So this is Lewis acid. This is Lewis acid. For example, here carbon is carrying positive charge, so this is also electrophile. This is known as carbocation, which is reaction intermediate. Here we are saying it is what they call it, electrophile. Then you are having nucleophile. It is nucleus loving, negatively charged species or electron rich species. Nucleus loving, negatively charged species or electron rich species. For example, you are having this. This is, say, cyanide, hydroxide, or you can have this ammonia, water, alcohol. So all these are nucleophile. Nucleophile. This is negatively charged or it is what they call it neutral species which are electron rich. It is Lewis base. So this is known as Lewis. Now Lewis base is also known as Bronsted base. Lewis base is also known as Bronsted base. All this comes from acid and base. All it comes from acid and base. So naturally, in order to understand basic concept, one should know acid and which is there in +1. So this is basic concept, this part of basic concept. So first of all, we have seen bond cleavage, then we have seen attacking species. Now let us see, because reactant is changing into product. So this is something, say, we are having this star. This star means reaction intermediate. So this is known as reaction intermediate. We can have this free radical, we can have carbocation, carbanion. So free radical is when atom or group of atom is having odd electron, resulting from homolytic fission. Atom species having atom or group of atoms having odd electron. Then carbocation, carbon, this intermediate when carbon is carrying positive charge. Carbanion when carbon is carrying negative charge. So this is something neutral, positively charged and negatively charged. Next comes their order of stability. In order to understand their order of stability, one should know the effects. For example, let me give you, I have given the formation of carbocation. Let us see the formation of carbanion. You are having this. So this hydrogen is gone, lost as. This is alpha hydrogen, alpha carbon, and you are getting this. So it means this whatever is lost as proton, that should be known as this alpha hydrogen is acidic in nature, again from acid and base. Whatever is losing, whenever hydrogen is lost as H positive ion, so that is something acid. So that is Bronsted concept or Arrhenius concept. So here it is, this hydrogen is acidic in nature, formation of carbanion. So what's the order of stability? That will be taken up after seeing certain effects. So those are again coming under the heading of basic concept. So first of all, we have seen bond cleavage, then we have seen attacking species, then we have seen reaction intermediates. Before we proceed further, how to explain their order of stability, how to explain their various types. So one should know the various, what they call it, effects. First is known as inductor effect. Second is known as electromagnetic effect. The third is known as mesomeric effect. So we are having inductor effect, electromagnetic effect, and mesomeric effect. So let us take them up one by one. Very important thing, because whatever these effects will be explaining, that will be determining the nature of product to be formed. For example, in Markovnikov's addition, you will be getting the formation of propane plus HBr giving you 2-propyl bromide. Why not 1-propyl bromide? Because secondary carbocation is more stable than primary carbocation. Why it is so? Because of inductive effect of alkyl group. So it should be taken up in detail. So because it will be explaining why certain products are formed in preference to others. So that will be explained in the basis of this. Similarly, electromagnetic effect. In that case, for example, alkyne are attacked by electrophiles. While carbonyl compounds, now what's carbonyl compound? C double bond O, aldehyde and ketone. Their nucleophile is attacking. Why it is so? It is because of electromagnetic effect. Then mesomeric effect. Mesomeric effect means, for example, if you are having phenol, if you are chlorinating it, ring substitution, then you will be getting the electrophile will be going to ortho and para position because OH is having plus mesomeric effect. It is something resembling the resonance effect. So here, how to take up all this? One should take them up, one should understand them. For example, let us take up inductive effect first of all. I think that's all for this video. We'll be continuing with this various effects, then taking up certain reactions. So I hope you must have been quite, what they call it, you must have learned a lot from this video. But again, I will be always stressing, don't consider anything complete in itself. When you'll be getting completion, when you'll be getting perfection, when you'll be going through the thing yourself, finding out your problems, understanding the things, and wherever you are having any problem, immediately that problem should be taken care of. If you will be following that practice, then 100% you will be having very wonderful chances of success. Otherwise, if you will be simply banking upon what they call it, other people, that somebody else will be coming and doing something for you, that is not possible. So always remember, you are yourself to make your future. So that's the final thing. So ultimately, I will always advocating that one should have maximum self-study, 7-8 hours self-study, and then whatever not clear, you can take the help of your friends or teacher or myself, and you can give me call at my WhatsApp number, which I have already given. So naturally, you should make use of that number again. So that's all for today. Thank you very much.